Hi class, it's Mrs. Kane and I'm here with our next e-learning lesson. Our next topic is compound interest. So recall from yesterday that we talked about exponential growth and exponential decay. Okay, and the two equations that we talked about for growth, we said we're going to take the initial amount p, we're going to multiply by 1 plus r to the t power. Okay, and r represents the rate in decimal form and t represents the time. Okay, and when we use these formulas, we're assuming that interest is being calculated annually. Okay, and annually means one time per year. So when interest is compounded annually, we just use the formulas that we talked about here. Okay. Now, in other situations, interest is not compounded annually. It's compounded more than once per year. Okay, and when interest is compounded more than once per year, we use something called the compound interest formula. Okay, and the compound interest formula looks like this. And what I want you to notice is that your variables are the same as the exponential growth and decay that we talked about yesterday. The only difference is we're introducing a new variable, n, and the n appears here and here. Okay? So when we use this formula, A is going to represent the new amount. This is the amount that we're looking for. We can think of it as the maturation amount. So after the investment, what's the new value of the investment? P represents the principal or initial amount. Okay, just like what we talked about yesterday. So initial amount, or we can think of P as the principal. Okay, that's the initial amount of the investment. R represents the rate. Okay, again, it's really important that we write that as a decimal. So you got to divide it by 100. Okay, and then n is our new variable, and n represents the number of times interest is compounded annually. Okay, and t still represents the time. Okay, so for example, if interest is compounded semi-annually, okay, then n equals 2. If interest is compounded quarterly, n is 4. Monthly, n is 12. Daily, we usually use 365 days, although obviously this is a leap year. Okay, so we'd have to be specific if we were asked about daily. Okay, so we're going to go ahead and I'm going to do a big example with you where we kind of practice using this formula. So Maria invests $14,000 in an account that earns 4% interest per year. How much money will be in the account after 10 years if interest is compounded? So we're going to calculate the amount if interest is compounded annually, semi-annually, quarterly, and monthly. Okay, so the reason I know I have to use the compound interest formula is because of this word right here. Okay, so if you don't see the word compounded, then you assume it's being compounded annually. Okay, so remember, if it's compounded annually, that means just once per year, so n is 1. And notice that if we look at this compound interest formula, watch what happens if we let n equal 1. So to find our new amount, we're going to start with the $14,000 that Maria invests. We're going to multiply by 1 plus r, 4%, 0.04, divided by 1, and then we're going to raise that to the n times t power. So n is 1 and t is 10 for 10 years. Okay, well notice that when you divide by 1 and you multiply by 1, the 1 just goes away, and so this just becomes a 0.04. And this just becomes 10. So when interest is compounded annually, you just really end up using the exponential growth model. Okay, so use your calculator to go ahead and type that equation in. Oops. Okay, and the new amount is going to be $20,723, and we're going to round to the nearest cent, so 42 cents. Okay, now if we want to know how much money Maria will have after 10 years if interest is compounded semi-annually, now n equals 2. Okay, so when we set up our equation, we're going to start with the 14,000. And then we're going to do 1 plus 0.04 divided by 2. And then our exponent, it's important that you make sure you type this product in the exponent. So depending on what kind of calculator you have to be careful here. So n times t, so we have 2 times 10. In this case, you might even want to just type 20 in your calculator. Okay, but most of you have the newer model, so you can go ahead and just type exactly as this appears. So in your calculator, we've got 14,000, and then we've got 1 plus 0.04 divided by 2, close your parentheses, and then in the exponent, you're going to do 2 times 10. If you have an older calculator, make sure you just type 20 as your exponent, or you put that in parentheses. Okay, so make sure that when you type it in, you get $20,803.26. Okay, one thing to be careful of is when you type in that 1 plus 0.04 divided by 2, don't type in 1.04 because only the 0.04 is being divided by 2, not the 1. Okay, so next one is going to be quarterly. So if you want, you can actually, we'll just write this out. I was going to copy and paste that equation, but I might grab too many things. All right, so we still have an initial amount of 14,000. 1 plus 0.04. Quarterly means 4 times per year, so n equals 4. So we're going to divide 0.04 by 4, and then our exponent is going to be 4 times 10, n times t. Okay, and so we're going to go ahead and type that in the calculator. 14,000 times 1 plus 0.04 divided by 4. That's where you have to keep those separated. And then this time the exponent is 4 times 10, or 40. Okay, and notice that the amount is getting a little bit bigger. So the more often that interest is compounded, the more money that you're going to make. Okay, so you should get $20,844.09. And then the last example is monthly, if n is 12. Okay, so again, this time all our numbers stay the same, except we're going to change that n value to a 12. Okay, so 12 times 10, so your new exponent is going to be 120, and then you can go ahead and type that in your calculator. Whoops, I think divided by 12 to the 120th power. All right, so again, we get $20,871.66. Okay, so notice the last question. In which of the above scenarios will Maria make the most interest and why? Okay, so notice she makes the most interest when it's compounded monthly. Okay, and that's because interest is added more often. So if you have an investment, when interest is added to an investment, you're actually making money. So now the bank is borrowing your money. So the more often that it is compounded, the more money that you're going to make. Okay, so I encourage you to go ahead and try the next 2 problems. Okay, maybe pause the video and then just kind of fast forward to the end and see if you got your answers right. Okay, and then I'm going to keep going for those of you that maybe need a little bit more support. All right, clear my calculator. So the next one, you deposit $5,000 at 3% interest for 10 years. How much money do you have if interest was compounded yearly, semi-annually, quarterly, and monthly? So very similar to the previous one. That's why I want to encourage you to do this on your own. Okay, so yearly, I'm going to let n equal 1. Semi-annually, n is 2. Quarterly, n is 4. Monthly, n is 12. Okay, so this time the initial amount of the investment is $5,000. So we're going to do 1 plus 0.03 divided by 1. N times t is just going to be 10. Okay, so in the calculator, 5,000 times 1 plus 0.03 to the 10th. And I don't even have to include the 1 there. Okay, so the first answer that you should get is $6,719.58. Okay, I'm actually going to go ahead and copy that first equation take a little shortcut here. I'm going to paste it. Maybe I'll change the color so we can kind of distinguish. I'm going to paste it again. And then I'm going to paste it one more time because all we have to do now is change the n value here. All right, so answer number 1 there, we got $6,719.58. So if interest is compounded semi-annually, I'm going to change my n value to a 2 and then n times t. Now I have to multiply my exponent 10 by 2. So my exponent's going to be 2 times 10, which is 20. Okay, so in the calculator, 5,000 times 1 plus 0.03 divided by 2. Whoops, I forgot my divided by sign. And then the exponent is 20. Okay, so that answer, we get $6,734.28. Okay, so if interest is compounded quarterly, I'm going to divide by 4, and then my exponent is going to be 4 times 10. So 5,000 times 1 plus 0.03 divided by 4, and now my exponent is going to be 40. Notice the amount is getting bigger the more often that we compound. $6,741.74. And then lastly, if interest is compounded monthly, we're going to use 12. So divide by 12, 12 times 10. Okay, so hopefully you're kind of fast forwarding through this part and checking your answers. Oops. Sorry about that. I must have hit something wrong on the calculator. Okay, so the last amount is $6,746, and we're going to round that to 77 cents. Okay. All right, the last question. A customer purchased a television set for $800 using a credit card. The interest is charged on any unpaid balance at the interest rate of 18% per year, compounded monthly. If the customer makes no payment for 2 years, how much is owed after 2 years? So the word compounded monthly, that's how we know we're using the compound interest formula. Okay, so the initial amount of the purchase is $800. We're going to do 1 plus 18% is 0.18 divided by 12, and then our exponent is n times t, so 12 times 2. Okay, I got that t from the 2 years. Okay, so you can go ahead and type that in your calculator. 800 times 1 plus 0.18 divided by 12, and then you're going to raise that to the 24th power and hit enter. And the answer is $1,143.60. Okay, so I encourage you to go ahead and do the Math Excel assignment. Problems that go with compound interest. I'm not going to assign an extra daily assignment for today, so go ahead and just do your Math Excel problems for today. Thank you to those of you that watch this, and I appreciate your patience as we try to navigate through